All right, so this is lesson 413. If you're watching this at home, you should solve it algebraically and graphically and see if you get the same answers. But right now you could pause the video and do that because I'm going to show you the answers now. Okay, actually I'm going to call on people here in my room for the answers. Oh, soon.
Wow, so the square root of something is
Don't land with an Easter egg.
I don't think you can sell anything. Can you buy me a kite for Easter?
What?
A what?
A kite.
For Easter? Okay, that was Cody Stevie just randomly asking a question that has nothing to do with the curriculum. Remember that anybody's welcome to watch these videos at home, parents or grandparents. Okay, here we go. I would like to remind everybody, since we are only at 11 days left, well, 11 days from now, but it's actually, what, 5 plus 4. 8 days after today is how many days are left of the quarter. If you're called on, you can do the problem, or you could say pass, or you could pass to someone specific, or you could even say something like pass to somebody who hasn't completed participation yet, and the calculator will call on someone randomly. If you want to be helpful to others. It is calling on Max. The first one.
He's going to pass. He's going to pass.
He needs to tell me that.
I'm going to pass his class.
Oh.
Okay, so for x, I got 1. So then the point would be 1, 2.
1, 2, he says. The answer is 1, -2, so he's incorrect.
I got it right.
All right. So, you need to say what you mean. Well, too bad. You should have. This is the math gods punishing you for not being unselfish and passing to others who have not completed their participation yet. Anyway, here's 1, -2. I got it by graphing and I got it by algebra. Pause it if you need. Next, it's calling on Austin. We're on the second one now. Okay, how generous of you. Now it is calling on Ashlyn. Would you tell me the point of intersection? X equals 1. Did you get X and Y or just X? Okay, so we do need an X and a Y on all these. You did the algebraic way or the graphing way? Algebraic, right? So you got 1, 1. What did the graphing people on the other side of you get? No, in her group. I got 2, 3 as well. Okay, you can see it's where this parabola's right here and this line's right here. They crossed at 2, 3. Algebraically, I'm not sure what everybody decided to do. I decided to set them equal to each other and multiply everything by 2.
Oh my gosh.
Okay, so once I multiplied everything by 2, I had x squared plus 2 equals 4x minus 2. I moved everything over to the left side. X squared minus 4x plus 4 equals 0. So then I solved by factoring x minus 2x minus 2, which gives me just that one answer of x equals 2. So x equals 2, then I plug that into one of these original equations. I chose 2x minus 1 and got y equals 3. Do you see what you did there? Okay. All right, on to the last one. Do you have a point of intersection for us? It's calling on Michael. All right. It is calling on 23. That's Jordan.
Michael Jordan.
That's my dad's name.
Oh, 23 Jordan. Huh, that is true. Okay, go ahead.
Well, one of the points I got was 0, -2.
Okay. What was another one you got?
2, 0, and then 4, 2.
So you got 3 points of intersection.
Is that right? I don't think you're staring at me, am I right?
Well, only one of us is right, I will say that.
What? No.
Because I didn't get the answer you got. All right, so first I'm going to show you, let's see, you did this by graphing, huh?
Yeah.
All right. So, well, did it give you a sideways parabola and a line?
Yeah.
Well, I only got them to cross twice, here and here. All right. And so those points I got were 4, 2, and 1, -1. Now, algebraically, this is how I did it. I decided that I didn't want to plug in for y. I preferred to plug in for x. So I got x by itself here and moved the 2 over. That way I could put y plus 2 in for this x. And then I had y squared equals y plus 2. So I solved for y first because I thought that looked easier. So hold that thought. Then I moved everything over, factored. I got y minus 2y plus 1, so y equals 2 and y equals -1 for my y's. And then I just plugged it into x equals y plus 2 and got x is 4 when y was 2, and x was 1 when y was -1. 4, 2, and 1, -1. Do you see?
Yeah. I'm just blind.
Oh, all right.
Don't worry, me too.
All right. Any questions right now? So what we're going to do now, you did?
I got 4 right.
I didn't think you said 4, 2, did you?
It was my little
Oh, this works.
I should get points for that. Why did I even erase this?
That's a good question.
You're a very nice
What do you
person.
do if you don't get one?
Okay, what's up?
What happens if you don't get all your participants?
Just keep participating.
I had one of mine right.
Don't worry about all that.
Really hard.
We're gonna... Everybody go to the next page, number 15.
15, you mean 37.
I mean 37. Thank you.
Where do you see 30?
I was looking at a different page. Here we go. Okay, listen. Seriously. We're recording. Okay. So what I'd like you to do now is we're going to do the same thing. We're going to solve this system right here. I'd like you to look at those two equations right now and give a prediction. How many solutions do you think this system of equations is going to have and why? All right? So take the next 30 seconds, predict how many solutions. It's okay if you're wrong, but make a guess. Remember, you're going to say how many and why. Why'd you predict that?
I said 2 because of the extra in the bottom of the board.
Actually, no, you give a calculator. 16 plus 9.
All right. Jenna. How many did you guess? You just had to make a guess. It's okay if it's wrong.
Can I pass?
I guess.
I already threw my participation point.
Oh, all right.
Generous, so pass to someone who or pass to Addie. She doesn't have her participation points yet.
I guess 2 because I have a feeling that it's going to be.
Yeah.
All right. Adeline guesses 2 because she has a feeling about it. We're going to see if that's correct. By the way, what is this graph?
X plus
But what kind of a shape? This is a circle. X squared plus y squared equals something is a circle. Okay? This one is a... Is it possible for a circle and a parabola to intersect each other twice? It is possible. What's the most amount of times a circle and a parabola could cross?
A lot.
Was I right?
A lot more than 4.
Okay?
Because what if the parabola's like
All right.
matching?
I could visualize 4 in my head. Okay? 4 times. How many? What's the least amount of times they could cross? 0. They could. One of them could be. The circle could be over here. The parabola could be over here. So they could cross anywhere, but as few as 0 or as many as 4. Let's find out by graphing this. Okay? We're not going to use Desmos. We could do this quickly. Tell me about this circle.
Has a radius of 5.
Radius of 5, and where's the center?
0, 0.
It's not shifted. So let's go ahead, thinking about that the center of the circle would be right here at 0, 0. I'm going to do a radius of 5, which means I'm going to go up 5, right 5, down 5, left 5. All right, and I'm going to make a circle. See how good of a circle you can make. I'm not real happy with my circle. I could have done better, but I did the best I could. All right. Now, this one's a parabola. Is it a sideways parabola or a up? It's a regular because it's x squared. It'd be sideways if it's y squared. So this parabola, though, is shifted down 13. So go down to negative 13. Put your vertex right there. Okay? We do not need so many comments. Okay? From that vertex, let's go over 1, up 1, because it's not stretched, right? Over 1, up 1. Over 2, up 4. 1, 2, 3, 4. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you drew your circle well, it appears that it hits the circle right there. Now, if I go over 4, I would go up 4 squared is 16. So if I go back to this vertex and go over 4, I would have to go up 16. So I'm going from negative 13 up 16 would be up to positive 3, right? So negative 13 up to positive 3 would be right here. And same thing on this side. Negative 4 up to positive 3. So now I think I can draw my parabola. And if you predicted 4 points of intersection, you would have been correct here. It's crossing 1, 2, 3, 4. Okay, so 4 solutions. Now, if you're confident in your graph, that these are the exact, that you could tell what these 4 points are, that would be good enough. You'd be able to state your answer. Okay, the answer are these points. Okay, sometimes either the graph is hard to tell because maybe they don't cross at nice places, or we didn't graph it great, so we don't know, we're not confident anyway, or we just don't want to graph in the first place. Okay, and we just want to solve it algebraically. So we're going to go ahead and solve this algebraically. And we don't have most of us don't have our books open, but what I'll tell you here is part C says to turn this system of equations into an equation that has only x's in it using substitution or elimination. Okay? This would be pretty easy right now to use I'm waiting for someone in the class to state. Substitution, right? Because I've got a y equals, and I could just plug y equals x squared minus 13 in for y. So let's go ahead and do that. X squared plus, and then I'm replacing y. Okay, I'm replacing y with x squared minus 13. So I'm going to put the x squared minus 13 in parentheses, but what do I still have there? That squared is not being replaced. We're just replacing y, not y squared. So don't forget to put the little squared up there, equals 25. There is an x variable only equation. Yes?
Would it be better to take the square root of the circle equation first, or would it be worse?
Okay, so I think this is what he's asking. He's saying to take the square root of this top equation and make it x plus y equals 5. Is that right? So I want to ask you this question, everybody. Do you agree with this statement?
Yeah.
All right. So is it mathematically legal for me to take the square root as he suggested and square root everything? Now it turns into 3 plus 4 equals 5. Do you agree with that statement? So that is not, it doesn't work mathematically for you to square root each of those. Even if these are all nice perfect squares, like these were, you can't square root things that are being added. Okay, so you can't square root through an addition sign. It doesn't work. So good question, but whenever someone asks a question like that, I always go back to making them real numbers and showing you that that really just doesn't work. All right, so let's go back to this. What the next part says is, now do a, instead of finish, we're not going to finish this problem right now. Let's do it again, but instead of making it an x equation, this time let's turn it into a y equation. And I'll show you. What if instead of putting a box around this and plugging it into here, what if instead I add the 13 over and make it y plus 13 equals x squared, and then I use substitution and plug it in to here? What would be the difference in doing that, other than the fact that we're plugging it in for x instead of y? Yeah, because now it's not just going in for, this one time it was just going in for y because it was y equals. Now it's x squared equals, so it goes in for the whole x squared. So I'm going to replace x squared with y plus 13 and write the rest of the equation. So let's write that down here below. Y plus 13 plus y squared equals 25. So take a look at those equations. Which one of these equations would be easier to solve? The x or the y? Doesn't it look, I mean, here it's just, we could move the 25 over and we've got a nice quadratic equation. Here, I would have to FOIL this out, which would actually turn it into an x to the 4th equation. So it's not even a quadratic equation anymore. It'd be an x to the 4th, which is generally a lot more difficult to factor, and you can't even use the quadratic formula, by the way. You can never use the quadratic formula unless it's a y squared as the biggest exponent. You can't do it on an x to the 4th because that's not a quadratic. All right, so I'm going to say the y equation is a quadratic. I mean, it's just easier. Looks like there's less steps, right? So let's go ahead and do that now. It says solve one of the equations from C. We're going to choose the one that's easier. I'm going to subtract the 25 over and make it y squared plus y minus 12 equals 0. So I got y plus 4, y minus 3. So now I've got y equals negative 4 and y equals 3. We've got our y solutions. Okay? Just like any time we're solving a system, we need to solve for x also. So now I'm going to take negative 4 and plug it into one of the original equations. I'll choose the top one. Okay, I guess I'll choose this top one. X squared plus y squared equals 25. All right, because x squared plus y squared, but negative 4 squared is 16, right? X squared plus y squared equals 25. Subtract 16, you get x squared equals 9, and what's x? Yeah, so you can't forget the plus or minus. So we just found that when y is negative 4, x is both 3 and negative 3. So I'm going to write both of those separately over here where it says solution. I've got the point 3, negative 4, and I've got the point negative 3, negative 4. Okay, don't we have those points in our graph? 3, 4 is right here. I'm sorry, 3, negative 4 is right here, and negative 3, negative 4 is right here. Those are those two. All right, now we'll do this with the 3. So plug the 3 into x squared plus y squared equals 25. It's x squared plus y squared, that's 9, equals 25. Subtract the 9, you've got x squared equals 16. And now you can square root that and get x equals positive or negative 4. And so now this says when y is 3, x is 4. So we've got the point 4, 3. And when y is 3, x is also negative 4. So negative 4, 3 as well. 4, 3 and negative 4, 3. We see that in our graph right there and right there. So the algebra works out and checks out to what our graph looked like. All right, that is the end of lesson 413. I'll show you what the assignment looks like for 413. You've got number 40, A, B, C, and D. These are 4 systems. Okay, you could use substitution or elimination on these. All right. Then for 41, you got just 4 normal equations. Well, I don't know if they're normal. One of them is a quadratic, one of them is a square root, one of them is a fraction, and one of them is a cubed root. By the way, the cubed root, what would I do first on this problem? Cube it. That'd be the opposite of the cubed root, right? Let's just cube each side. Cubing the cubed root would just cancel it out and leave us with whatever's under the radical. 1 minus 2x. And 3 cubed is 27. There's your new equation. You solve that, you have the answer. All right. We're going to skip 42. Not because you shouldn't know how to do it, but because it is the checkpoint 4A, and you're doing 1 through 20 on the checkpoint. It's the same kind of problems. Plus, it got cut off anyway. So just cross 42 out and leave that out of this assignment. But there is one more page. Okay, on 44, you're just finding the slope and y-intercept of those 3 problems. Okay, and then 45 is a domain and range problem by looking at the graph. All right, that should do it. I'm going to stop the video.